Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Welcome to today's explainer. We are jumping right into a massive foundational methodology in software development today: black box testing and boundary value analysis. If you've ever wondered how QA teams actually ensure an app doesn't just instantly crash the second you try to use it, well, you're in the right place. We're going to decode exactly how professionals test complex systems from the outside in. But before we really get going, let me throw a crucial question your way. How exactly do you test code that you can't even see? Imagine someone hands you this incredibly complex machine, but the entire casing is completely sealed shut. No way to see the gears, the wiring, the engine, nothing. All you can actually do is press the buttons on the outside and watch what pops out the other end. How do you guarantee that machine works perfectly every single time? That is the core puzzle we're solving today. All right, Section 1, Inside the Black Box, Testing the Unknown. So let's get a clear definition on the board. Black box testing is basically testing against a system where the code and the internal paths are entirely invisible to you. And honestly, black box is literally the perfect metaphor here. You aren't looking at any source code. Instead, your whole approach focuses completely on the output that gets generated by a given input. You punch in an input, you press the button, and you just observe exactly what happens next. Think of it like this. On one hand, the tester knows the inputs, the expected outputs, and the user's perspective. But on the flip side, they are totally in the dark about the internal code and the internal mechanics. It's an entirely input-output driven approach. You have absolutely zero knowledge of the underlying code. Now that might sound like a huge disadvantage at first, right? But it's actually an incredibly powerful perspective to have. And because this methodology is so foundational, it's also incredibly versatile. You can apply this at virtually every single level of software testing. It scales all the way from unit testing, where you're checking those tiny individual components, up through integration testing, and all the way out to massive acceptance testing and even security testing. It's a universal framework that just works across the board. Now you might be wondering, why is this so universally adopted? Well, the biggest advantage of black box testing is that it focuses 100% on the user perspective, functionality, and usability. By keeping the code hidden, it literally forces the tester to interact with the software exactly like a real end user would. I mean, an everyday user doesn't care about the backend database logic, right? They just care if their login works smoothly. This method guarantees the software actually delivers what people need in the real world. Moving right along to Section 2, Boundary Value Analysis Explained. Finding bugs at the edges. The logic behind this specific technique is so fascinating. Boundary value analysis, or BVA, is built on this really interesting psychological and logical premise. Errors almost always occur at the boundaries of an input domain rather than right in the middle. It's like a universal law of programming. Bugs absolutely love to hide at the absolute edges of the rules. If you think about it, developers usually get the middle of the road perfectly right, but those exact cutoff points, that is exactly where logic errors thrive. So to actively hunt down these boundary bugs, BVA relies on a highly specific, methodical three-step sequence. Step 1, you test the exact boundary. Step 2, you test one step below that boundary. And Step 3, you test one step above it. You are basically systematically poking at the fences of the software's logic to see if they hold up under pressure. Okay, Section 3, Real-World Testing Examples, Putting BVA into Practice. Let's make this super concrete with an everyday scenario. Imagine you're signing up for a new online service, and you hit a password field. The rule is incredibly strict. It only accepts 6 to 12 characters. We have all seen this exact prompt. So, how do we test it efficiently with BVA? I mean, we definitely don't have time to test a 1-character password, a 2-character password, all the way up to 100 characters. We need a targeted approach. So let's map out our 3-step rule to those 6 and 12 character limits. Down at our lower boundary of 6, testing 5 characters should definitely be invalid and rejected, while 6 and 7 must be accepted. Then jumping all the way across to our upper boundary of 12, 11 and 12 characters are perfectly valid. But the very second we hit 13 characters, the system must reject it. By testing just these 6 specific edge cases, we've effectively secured the whole entire field. Let's look at one more scenario, just a simple numerical one, to really lock this concept in. Imagine a standard number field on a web form, and this one specifically only accepts values ranging from 0 to 99. Applying that exact same logic to our 0 to 99 range,
We check just outside the lower fence at -1, which should absolutely fail, while 0 passes with flying colors. On the high end, 99 is perfectly valid, but stepping just one single unit above that to 100 must trigger an error. We aggressively target these exact edges because, time and time again, experience tells us that is where the system is the most vulnerable.
So to wrap up our explainer today, I want to leave you with something to think about. Where else in your digital life are hidden boundaries just waiting to break? Every single time you use a mobile app, fill out an online form, or even play a video game, you are interacting with these invisible boundaries set by developers. The next time you hit a limit, whether that's character counts, date ranges, or how many items you can put in a shopping cart, remember the black box tester and remember the power of boundary value analysis. You might just start seeing the digital world entirely differently. And hey, who knows? You might just spot a bug hiding right there at the edge.
Thanks so much for joining me for this explainer today, and keep exploring those boundaries.